Okay, let's do a few problems where we rely on the lens equation and a few things about lenses. I wrote the lens equation up here. 1 over s prime plus 1 over, 1 over s plus 1 over s prime is 1 over f. So s is the object distance to the lens, s prime is the image distance, and then f is the focal length. We could talk about the magnification in terms of object and image distances as well. So the magnification m is minus s prime divided by s, and it's also equal to h prime divided by h. And h prime is the image height, and then h is the object height. So primes always go along with the image, non-primed, so non-primed go along with the object. And it takes some getting used to, but it's not too bad. Let's just dive right in with 31 here. So in this problem we're supposed to calculate the image position. So we want to find s prime and also the height. So the image position and height. Good. So hopefully from these two equations, this is really what it comes down to. We can find this. So a 2 centimeter tall object, so h is 2 centimeters, is 15 centimeters in front of, this is number 31, so 15 centimeters in front of a converging lens, so s is 15 centimeters, and we know the focal length of the lens, 20 centimeters. Good. So we should be able to use the lens equation to figure out where it's located, and then once we know where it's located, we can use this relationship here to figure out what the height is, because then we'll know s prime s, and we're given what h is. So let's first of all get s prime. So using the lens equation, I can solve for s prime. 1 over s prime is 1 over f minus 1 over f minus 1 over s. So taking this equation, rearranging it for putting s prime on one side. So let's see, 1 over f, so 1 over 20 centimeters minus 1 over 15 centimeters. So you can use your calculator to do this, or if you want you could try to find a common denominator. However you want to do it. It looks like, but just by looking at it, maybe 300 would be a common denominator. And I could say this would be 15 over 300 centimeters minus 20 over 300 centimeters. That would be 1 over s prime. Or again, if you wanted to, you could just put it in your calculator right away. 1 divided by 20 minus 1 divided by 15. So this would be minus 5 over 300 centimeters. That would be 1 over s prime. So then I can invert it to figure out what s prime is. So take this equation here, let me just call it equation 1, and put it over here just to save some room. So I'm taking that equation and flipping it upside down. So s prime then would be equal to minus 300 centimeters divided by 5. So s prime then is minus 60 centimeters. Good. And then I could use this relationship here and solve it for h prime. So minus s prime over s, multiply both sides by h, and that's equal to h prime. So I took the equation here at the very top, this part of it really, and solve for h prime by multiplying both sides by h. And now I can put some numbers in. So let's see, minus s prime, so minus 60 times h, and h was 2 centimeters, and then divided by s, which was 15 centimeters. Okay, so the minus signs cancel out, this becomes positive. So it looks like I have 8 centimeters as the image height. Good. And you can check out that the magnification works whether you use h prime divided by h, or minus s prime divided by s. Okay, great. Going on to the next one in just a second.